Hello team, welcome to the Learn via elearn.com classes. So in today's class we will learn about red black tree. Alright, so what are the things we are going to cover? We will cover about from the very basic understanding about what is red black tree, right? And we will see the properties of a red black tree with some examples. Alright, we will also see the relations of 2, 3, 4 tree, right? And then we will see the insertion in red black tree also, right? So these are the few topics which I will cover in my today's class. It could be possible that probably while explaining the things it may exceed to my second part, but I will try to wind up in my this class only. Alright, so let's start with our basic question about what is red black tree. So red black tree, let me write it down the basic property or basic definitions or what you say. Okay, so let's write what is red black tree. Okay, so first property or a first basic thing about red black tree is red black tree is a binary search tree in which each node is having color, okay, is having a color field of red or black. Okay, so what is red black tree? A red black tree is a binary search tree which is having a node which is colored, okay, and those are colored with either red or black. Number 2, every node is either red or black, but the root is colored as black, right? So every node is either red or black, but the root is colored black only, right? Now number 3 property is very important. A red node has only black children, right? Black could be black nodes could be of red children, but a red node has only black children. All right. Similarly, in another word, if I say a red node has only black parent, okay, both are same. Team, after explanation of this property, I will draw and show you how these all properties qualifies in a red black tree. Okay, so don't worry about any specific statement or any specific property if it's not clear as of now, right? It may possible that it's you are not visualized about how red black tree actually looks, right? But let me finish it out with our basic property. right? And then I will draw a actual red black tree. All right. Okay, now the fourth property is, if a node of the binary search tree does not have a left and or right child, then we add an external node, what we also called as a nil node. Okay, team, we generally think any binary tree like this way. Like for example, if I just draw any binary tree, okay, it may look like somewhat this one. Okay, this been connected with this way, this node is connected with this way, it's like this. Okay, but here in red black tree we have one more property. Let me add one more node here. Okay, so in red black tree, every leaf node must be having either left or right or both external node, which we can uh, draw uh, like this way. Okay, this node is called as an external node. Okay, this node already have one child, so this node is having only a one external node. Okay, so here we have a concept of external node, what we also called as a nil. Okay, and these nodes are black in color. So we have two nodes which is in black for sure. One is our root node and next is our external nodes. All right, so let me continue with my properties. Oops, let me draw like this. Okay, let me change the color also. So the next property is external node, what we also called as nil. Nil pointers are also in black colors. Okay, now we have something called as a black depth. It's very important. See, the black depth of external node, actually we used to calculate the black depth of this red black tree. How? We will see. So the black depth of an external node is defined as the number of black ancestors it has. Okay, so to get the black depth, we will see how many ancestors we have in a particular binary search tree of red black tree. Or in another words, if I say all simple path from any node let's say X, to a descendant leaf have the same number of black node, which is also called as a black height. This is the main property of a black depth, of a red black tree. Okay, now let me draw a figure and I will explain you these property, how it's qualified in that graph. Now let's say we have uh, a red black tree like this. Let me draw it first. Okay, so we have some external nodes also like this. These are some my external nodes which is connected with my leaf nodes. Okay, so if I ask that, first of all, is it a binary search tree which is of red black tree type? Let's see. What are the properties? A red black tree is a binary search tree in which each node is having colored fields, which is, yes, we have a colored field, red and black. Now every node is either black or red, but the root is colored black. Yes, my root is colored as a black. Yes. Now the every node, yeah, a red node has only black childrens, right? So a red node has only black childrens. This is also qualifies. Or we can say a red node has only black parents. Okay, red node has only black parents. Okay, this is also right. If a node of the BSG does not have left and or right children, then we add an external node or nil. So here we have added a external node of every leaf node. Okay, now external nodes are in black colors, so we have marked in a black color. Okay, now comes the calculation of black height. If I ask what's the height of this external node, means how many black nodes we have if I travel uh, from any external node. So we have how many nodes which is in black? 1 and 2. Similarly, if I travel from this node, again we have 2. If I travel from this node, this external node, then again we have 2 nodes, 1 and 2. In a similar fashion, if I travel from any of the external node, we have only 2 black nodes. So what's the black height of a tree? If I say black height of a tree here is what? Is 2. Because if I travel from any of the external nodes, it comes as a 2. Alright. Now let's take some complex example. For example, um, let me draw like okay, So this is one of my node, a root node I would say, and under which I am designing some other nodes like uh, this. Okay, and under this node, let's say I have two more red nodes, and a red node must be having a black nodes only. So let's say I have one more, and red node could be have red. Sorry, black node could be have red. Okay, so now uh, let me connect it. So connection would be like this. Okay, okay, now let me put it some figures also. Let's say this is 8, this is 4, this is 19. Okay, this is for example 11, this is 12, this is 9. Team, I am just making this graph in a way that all the left side should be smaller than on my right side, right? So this is 23 and right side would be greater than 23, so it comes for example 27. Okay, now if I, what's the black height? So for that let me draw some external nodes also. So external nodes would be like this. Okay, this leaf node must be having two external nodes, or in case of 23 vertices we can see we have only one external node here, right? So if I calculate from external node, the height would be 1 and 2. Okay, so this is my first node, this is my second node. If in case of here, again my height is 1 and 2, right? Here we have how many, what's the black height of this graph? Again we have 2. So we have seen basic three properties here. Number one, no red node has a red child. Okay, so these are some key points, some key elements which we need to consider whenever we saw any red black tree. Okay, so no red node has a red child. Number one. Number two, root is black. Okay, and the number three is black height of every external node is same, right? Like if I calculate from any external node, for example from here we have 2, from here again we have 2, right? So external node, from external node if I calculate the black height of any tree, if it's a black if it's a red black tree, then it comes as a same. So this is my red black tree. Now see one more tree. It's like this is one of my vertices, and we have one vertex like this. Let me draw a red vertex here. Let me draw a red vertex here, and then we have some nodes like this only, and we are connecting these vertices as like this. and we have some external nodes also there. Let's say these are some external nodes of this graph. Okay, team, if I ask if this is a red black tree or not, it's very easy, because if I go through my conditions which I have explained here, like this graph is violating one of my basic condition. What was that? Plain that no red node have any red child, right? If I see that a red node has only black children, but here in this case a red node is having a red children. Okay, so this is my culprit, due to which this